Good day to one and all. I am Ms. T. Revati, Assistant Professor, Department of Chemistry, Auxilium College, Vellore. Today, we are going to learn about the concept of normality. In this video, I am going to explain calculations of concentration in terms of normality step by step. In the first half of the video, I will teach all the necessary basics about normality and its calculation. In the second half of the video, I will solve all the problems related to it. These are the learning outcomes. At the end of the class, you shall be able to define normality, calculate normality of any given solution, prepare different normal solutions from solids and liquids. First, let's learn what is concentration. Concentration is an expression of how much solute is dissolved in the solvent in a chemical solution. There are a number of ways to express concentration like molarity, molality, mole fraction, percentage, normality, etc. Today, we are going to learn about normality. Technically, normality is defined as the number of gram equivalents of solute present in 1 liter of the solution, and it is denoted by N. The number of gram equivalents of solute is equal to weight of the solute divided by equivalent weight of the solute. That is, gram equivalent is equal to W by E. So, normality is equal to weight of solute in grams divided by equivalent weight into volume in liter. So, we can simply say N is equal to W by EV. Remember, here weight is in gram and volume is in liter. In case if volume is given in ml, then we should convert it into W by E into V divided by 1000, or simply N is equal to W into 1000 by EV. You would have used the term decinormal solution of NaOH in your practical. Let's see what does that mean, and also about other general terms used. The first one is normal solution, which refers to one normality of solution. That is, solution that contains 1 gram equivalent weight of substance per liter of the solution. Second one is semi-normal solution, which refers to 0.5 N. Decinormal solution refers to 0.1 N. Binormal solution refers to 2 N. The unit of normality generally used is N. And equivalent per liter is used rarely. Let's see in what are the possible ways calculation of normality is used in practical. With just one simple formula, N is equal to W by EV, we can do various type of calculation. We will discuss it one by one. The first type of application is calculating normality if weight and volume is known. This involves direct usage of formula. You can see here. Example question of this type is, what is the normality of NaOH solution if 4 gram of NaOH dissolved in 100 ml of water? You can see here weight of NaOH and volume of solvent is given. The second type of application is calculating weight if normality and volume is known. Example question of this type is, how much gram of NaOH is required to prepare 0.5 N NaOH solution for 100 ml? You can see normality and volume is given here, and we need to find the weight. Remember, in type 1 and type 2 applications, we have seen solute in the solid phase and solvent in the liquid phase. So, we use the formula W by EV. Moving forward, we are going to see how to prepare particular normality of solution if both solute and solvent are in liquid phase. Since solute is also in the liquid phase, we must not weigh it to find W. Then, what is the method to find the amount of solute? That is going to be our type 3 application. Here, normality and volume is given, W is unknown. The only hint which we need to observe in the question is density and purity of solute. Example question of this type is, how will you prepare 2N HCl solution for 1 liter from 95% of pure HCl? Here density of HCl is missing, but it is a standard value. In type 4 application, in place of weight of solute, normality of solute is given. That is, concentration of solute is given. Then how to prepare particular normality of solution? Example question of this type is, how will you prepare 100 ml of 0.5 N HCl solution from 2 N HCl solution? Note, type 4 application is applicable only if normality of solute or the stock solution is greater than the normality of the solution to be prepared. We can prepare diluted solution from concentrated solution, but we cannot prepare concentrated solution from dilute solutions. So you can see here we cannot prepare 2N HCl from 0.5N HCl because 0.5N is lower concentration and 2N is higher concentration. We cannot prepare higher concentrated solution from lower concentrated solution. Finally, I have come to the end of first half of my video. I hope you understood all the basics. Come on, now let's see the problems related to all the basics which I have taught now. Let's solve problems related to type 1 first. Here, weight and volume will be given and normality needs to be found out. The first question is, calculate the normality of solution of NaOH if 4 gram of NaOH is dissolved in 100 ml of the solution. You can see here the weight is given as 4 gram and volume is given as 100 ml. Here the volume is in ml. So to convert it into liter, we need to divide it by 1000. See here, we are substituting the weight as 4 and equivalent weight. I taught you how to calculate it in the previous video. You can learn from that. Equivalent weight of NaOH is 40 and the volume in liter is 100 ml divided by 1000, which will give you the volume in liter. On substituting, you get the normality as 1N. The second question is, when 0.321 gram of sodium carbonate is mixed in a 250 ml solution, determine its normality. So first we need to calculate equivalent weight of sodium carbonate, whose molecular weight is 106 divided by its valency is 2. So you get 53. Again here volume is in ml, so we need to convert into liter. Whenever the volume is in ml, we can simply rearrange the formula like this. N is equal to W into 1000 by EV. W is weight, which is 0.321 into 1000 divided by E is equivalent weight, which is 53, and volume is 250 ml. On substituting, you get normality is 0.024. Okay, you can now solve this problem on your own by pausing the video. In this slide, we are going to solve problem related to type 2, in which normality and volume is known, weight is unknown. The first question is, how many gram of NaOH are required to prepare 500 ml of a 0.5 N solution? We need to find the weight here and see volume is given in ml again. So we slightly change the formula previously used to get W. So W will be equal to now NBE by 1000. Equivalent weight of NaOH is 40. Volume is 500 ml and normality is 0.5 N. On substituting all the given values, we get weight is equal to 10 gram. This problem doesn't stop here. are we going to prepare the solution? So to prepare 0.5 N normality of NaOH for 500 ml, we need to weigh exactly 10 gram of NaOH and dissolve it initially with little amount of distilled water and then dilute the solution to a final volume of 500 ml with distilled water. In this problem, we were asked to prepare decinormal solution of oxalic acid. I hope by now you all know what is decinormal solution. Yes, it is 0.1 N solution of oxalic acid. Now you can try solving this equation on your own by pausing the video. In this slide, we are going to solve problems related to type 3, in which both solute and solvent are in liquid phase. This question needs to be solved systematically, but I prefer using this simplified formula to solve the question quickly. And that formula is normality of X percentage of solution is equal to percentage purity into density into 10 divided by equivalent weight. This formula should be used only if the solute is in liquid phase. Usually when acids are prepared, this formula can be used. Here, percentage purity, density and equivalent weight refers to purity, density and equivalent weight of solute respectively. And 10 came from simplification from the systematic derivation which I stated before. Coming to problem now. The first question is calculate the normality of commercially available 36% pure HCl having density 1.18 gram per centimeter cube. Here equivalent weight of HCl is 36.5. Purity of HCl is 36% and density is 1.18 gram per centimeter cube. On substituting these values in the above formula, we get normality of 36% pure HCl is 11.64 normality. Here normality of solute is determined. Now to prepare solution of required normality, we can use type 4 formula which we will be seeing shortly. So now we have found only the normality. Once again, you can pause the video and solve this question on your own. This slide is about type 4 problems. Again, here both solute and solvent are in liquid phase, and instead of weight, normality of solute is given to find normality of the solution we are going to prepare. We should use the formula B1N1 is equal to B2N2. I hope you would have seen this formula before. This is generally called as normality formula or law of equivalence formula. If you are confused what is N1, B1, B2, N2, etc., you can rewrite it as VKNK is equal to VUNU. VKNK are volume and normality of solution to be prepared, and VUNU are volume and normality of solute. Okay, so now let's solve the problems. The first question is how many ml of 2N HCl solution will be required to prepare 0.5 N solution of 500 ml. Here we need to prepare 0.5 N solution of HCl from 2N HCl solution. We can see the concentration of solute is greater than concentration of solution to be prepared. So we can use the above formula to solve, which is PKNK is equal to VUNU. As I've already told, PKNK is for solution to be prepared, VUNU is for solute. So BK is for solution to be prepared. So what is the volume of solution to be prepared? 500 ml. What is the normality of solution to be prepared? 0.5. And we don't know the volume of solute to be taken. And what is the normality of solute we have? 2N. So on substituting, we can find what is the volume of solute need to be taken. So we have found it to be 125 on substitution. So from this, we conclude that 125 ml of solute needs to be taken to prepare 500 ml of 0.5 NHCl. Remember, you should always add acid to water and that too along the sides of the container. You can pause the video and solve this question. This is slightly a tricky question. If 25.2 ml of 0.2703 N acid reacts with 35.1 ml of base, what is the normality of the base? Here we use V1N1 is equal to V2N2 formula for acid-base reaction. The reason behind this is in any neutralization reaction of acid-base, gram equivalent of acid will be equal to gram equivalent of base. That is, gram equivalent is W by E. So, W by E of acid will be equal to W by E of base. We know normality is equal to W by VE. Now we are getting W by E out of it, which will be equal to NV. So, substituting W by E is equal to NV, we get multiplication of normality and volume of acid will be equal to multiplication of normality and volume of base. So, we get this formula V1N1 of acid is equal to V2N2 of base. That's how we arrived at the formula. Now, solving this as usual, you can find normality of base. Similarly, you can find normality of acid. Kindly pause the video and solve this question. This is the summary of this lecture. All the above discussed expressions are widely used in chemistry lab for preparing various reagents and diluting the stock solutions. Normality is used to express the gram equivalent weight of solute in a solvent. A lower concentration of solution can be prepared from higher concentration of solution by diluting using normality equation. Now it's time for activity. You can practice all these problems given here and find the answer on your own. These are my references. Thank you.